Hi, this is Dr. Dave, and in this video I want to show you how to find the present value of an annuity. By that I mean we want to find how much would you deposit at one time and let grow with compound interest so that the amount would be the same as making payments over the exact same time. So here's the formula that we're going to be using. On the left hand side you'll see the compound interest formula. And on the right-hand side, you'll see our future value for the annuity formula. Remember, the P is the present value. The I is the interest rate per period. The N is the number of periods. And the R is our payment. So let's go ahead and use this formula to find the present value of an ordinary annuity with payments of $90,000 paid annually for 25 years at 8% compounded annually. What I'm going to be solving for is P, 1 plus the interest rate per period. Now, it said we were making annual payments, so that means our interest rate per period is 8%. And it said we were going to do this for 25 years, so that's 25 periods. That's going to be set equal to the payments, so we're making $90,000 payments, so that's what I put in for R. And then what's in the brackets there is going to be 1 plus 0.08 raised to the 25 minus 1 all over 0.08. So I need to work out what's on the right, and then to get what P, I'm going to divide by this piece in parentheses. So let me work this part out on the right in my calculator. And the way that makes it a little bit easier is if I take those big brackets out and use a set of parentheses around the top. And if there was a fraction in the bottom, I'd use parentheses there, but here I can just go ahead and divide by 0.08. So let's go ahead and do that part on the right. So we're going to take 90,000 parentheses 1 plus 0.08 end the parentheses raised to the 25, subtract 1, group everything on top. We're going to divide that by 0.08. So what I come up with on that is 657,953.596. I'm going to work out what's on the other side, and then I'm going to divide that into this big number here. So let's work out the part in parentheses on the left-hand side. So we're going to have parentheses 1 plus 0.08 end the parentheses raised to the 25th. So we're going to have P times 6.848475196. In order to get the P by itself, I'm going to divide both sides by that big long decimal that I just found, 0.848475196 on both sides. And on my calculator, I'm going to make that a little bit easier. So I'm going to type in the top number, 657,953.596. 0.596. I'm going to check that number again, 657.9534.596, and I'm going to divide it by the previous answer. When I do that, I get P, the present value, is equal to 960,729.86 to the nearest penny. So what that means is I can make payments of $90,000 for 25 periods at 8%, and that would end up accumulating this $6,579,334.5960. Or I could deposit $960,729.86 in one lump sum for 25 years, and it would amount to exactly the same amount. Now, the way that I've done this here is I've gone ahead and worked out these pieces and included all the decimals, but I can avoid a little bit of having to write down all those decimals if I calculate it this way. So let's say that I work out the part that I did on the right-hand side, the 90,000, parentheses, parentheses, 1 plus 0.08, and the parentheses, raised to the 25th, minus 1, and then divide that by 0.08. Hit enter. That's the number that we got before. And now instead of writing this down, I'd probably write it down to make sure, if I have to go backwards, I have something to go backwards to. But let's say we divide that now by 1 plus 0.08 and the parentheses raised to the 25th, enter. I get the exact same number here, but I didn't have to worry about having to type in all those decimals, which sometimes is really easy to make mistakes on.